this video, I want to introduce the topic of energy. Energy is a useful tool that we have available to us for analyzing dynamic problems. Of course, we know about the conservation of energy and that we can measure the energy of different situations. And that fact makes it useful to us when it comes to looking at what's happening in a dynamic system. So to start with, we have two basic forms of energy that we want to think about. First, we have potential energy. And potential energy we can also think of as stored energy. So for our purposes, we can store energy in different ways. One of the most common ways to store energy would be in holding some mass at a height. So if we were to represent the potential energy of that situation, I'm going to write it with a capital letter U, or designate potential energy with a capital letter U. And I'm going to say that the energy is equal to mass times gravity times height. So this is basically exactly as it sounds. If I have some mass, let's call it a ball maybe, and it is at some height above the ground, that has energy stored within it. And the reason we know it has energy is because if I release that ball from that height, it's going to gain velocity and change state of energy due to that force of gravity acting upon it. Another classic form of potential energy or stored energy is in the form of elastic stored energy. So this could be in a spring or in a rubber band, and if that spring or rubber band has some sort of elastic response, meaning that if I push on it with some force and it deforms by a certain amount, and when I release that force it returns to its original shape, I can calculate the amount of energy contained within that deformation of that thing. So we have the equation here, U equals 1/2 kx squared, or sometimes written 1/2 k delta squared, where the k is the elastic coefficient, how much force it takes to deform by a certain amount, deform the object by a certain amount, and the x squared, or the delta squared as it's sometimes written, is how much deformation we've subjected that thing to. So both of these can be particularly useful for us. When it comes to looking at dynamic problems, then, the other form of energy that we're going to be particularly interested in is kinetic energy. And kinetic energy is the energy of motion. So if we have an object which is undergoing any sort of motion, whether that's translation or rotation, it is using energy or displaying a use of energy. So for my purposes here, I'm going to denote kinetic energy with a T, and I'm going to say that our basic equation to start with is 1/2 mv squared. So we have 1/2 times the mass of our object times the velocity that it moves at squared. Now, for energy, our units are going to be joules. Joules in this case can be broken down into Newton meters, which we could break down further into kilogram meters squared per second squared. So if we look at the units, we can get a little bit of a better sense of how these equations that we've written over here fit into that framework of the units of total energy. And energy, again, as I mentioned at the beginning, is useful from the perspective of we can take our conservation of energy principle and use that to write equations and understand the state of motion for an object given its initial and maybe final conditions. Depending on what we know, we can create a system of equations and unknowns that we can solve in dynamic problems. Thanks.